Hi there. In this section, you are going to learn how to define a complex number. So let's begin defining complex numbers. In order to define a complex number, what I'm going to do, I'm going to consider an example first. So this is my expression x square plus 1 is equal to 0. What I would like to do, I would like to solve this quadratic equation. So in order to solve that, I need to get rid of 1. And to do that, I'm going to subtract 1 from both sides. And if I do that, I will cancel this thing out and I will get x square is equal to -1. So as you can see, x square is equal to -1, where right hand side is a negative number, and if we find the square root of a negative number, we will get x is equal to plus minus square root of -1. As we know that there is no square root of negative number. What I mean to say that we cannot get a real number for a square root of negative number. So what I'm going to do, I'm going to consider a notation which is basically I is equal to square root of -1, and this I is known as eta. So if I rewrite this expression, I will write x is equal to plus minus I, where I is equal to square root of -1, and this is a complex number. If I simplify the roots of the quadratic equation, I will write x plus I times x minus I is equal to 0. So what I'm going to do, I'm going to first consider this first root for the quadratic equation, and if I do that, I will get x is equal to -I. If I rewrite this expression, I can write x is equal to 0 plus -1 times I, where this is my real part of the complex number and this is my imaginary part of the complex number. And always remember that imaginary part of the complex number is always with I. So I can rewrite x is equal to real of x plus imaginary of x. So if I compare these two, I can write real of x is equal to 0 and imaginary of x is equal to -1. And if I want to rewrite these numbers like real and imaginary part of the complex number in terms of the ordered pair, I will write ordered pair is equal to 0, -1. Now it's time for us to solve the second root of the quadratic equation, which is x minus I equals to 0. So if I do that, I will write x is equal to I. And this is basically x is equal to 0 plus 1 times I. So this is my real part and this is my imaginary part of the complex number. So I will write x is equal to real of x plus imaginary of x. So if I compare and rewrite, I will write real part of x is equal to 0 and imaginary part of x is equal to 1. And these numbers can be written in ordered pair as ordered pair is equal to 0, 1. And this is how we will solve a quadratic equation with no real root. Now let's define a complex number. So a number of the form z is equal to a plus ib is called complex number. So basically, if you see a number which is written in the form of z equals to a plus ib, then that number is a complex number. So what I'm going to do, I'm going to rewrite z is equal to a plus ib over here. So this is my same complex number from here, where a is my real part of the complex number and b is the imaginary part of the complex number. So if I have to write the real and the imaginary part after extracting from the complex number, I will write real part as real part of z is equal to a, where z is a complex number, and imaginary part of the complex number z is equal to b. So basically, as we can see, a complex number is made up of real and imaginary part. Now let's consider an example to understand the complex numbers. So the example is, describe the complex number z is equal to 5 plus 7i. So as you can see that real part is my first number without I, so I can write real of z equals to 5, and imaginary part of the complex number z is im of g is equal to 7. And this number can be written in ordered pair as 5, 7. What I would like to do, I would like to represent this complex number graphically. So here is my graph. Let this is my x-axis, this is my y-axis, and this point is the point of intersection of x and y, which is O, and which we call origin. I want to graph this ordered pair 5, 7. So I'm going 5 along the x-axis, 1, 2, 3, 4, 5, and then the 7 along y. So 1, 2, 3, 4, 5, 6, 7. And this is my point P, 5, 7. So basically what I did go 5 unit along the x-axis and 7 unit along the y-axis. And if I want to find the magnitude of this complex number, I should connect it with origin. So basically this arrow with blue, and to find the magnitude of OP, I can use the distance formula, which will be a square root of a square plus b square. So I can write OP, which is the magnitude of the complex number, is equal to a square root of a square plus b square, where a is 5 and b is 7. So what I'm going to do, I'm going to substitute a and b over here. And if I do that, I will write OP is equal to square root of 5 square plus 7 square. So 5 square is 25 and 7 square is 49. So 25 plus 49 is 74. So I will write OP is equal to square root of 74. And this is the magnitude of the complex number Z is equal to 5 plus 7i, which is over here. And this is how we will find and describe the complex numbers.